So here we are, uh, a question on determination of scalar triple product. So we have three vectors: a vector which is equal to 2i cap plus j cap plus 3k cap, b vector is equal to minus I cap plus 2j cap plus k cap, and c vector is equal to minus 3i cap plus j cap plus 2k cap. So we have to find out the scalar triple product a vector, b vector, c vector in that proper order. So we know that the scalar triple product involves the determinant of the respective components x, y and z in the proper order. So first we'll write the x, y and z components of a vector, that is 2, 1 and 3. Then the x, y and z components of b vector, that is minus 1, 2 and 1. C vector is minus 3, 1 and 2. The determinant of this, that will be the scalar triple product. So then we'll just do the usual determinant calculation. So 2 into 2 into 2 minus 1 into 1, then minus 1, I'm going by this way, okay, 2 1 3, that minus 1 into minus 1 into 2 minus 1 into minus 3, then plus 3 into minus 1 into 1 minus 2 into minus 3. Okay, so this becomes 2 into 4 minus 1 minus 1 into minus 2 minus of minus 3, which is minus of minus 3, which becomes minus 2 plus 3, and then plus 3 into minus 1 minus of minus 6, which becomes plus 6. Okay, this minus 1 plus 6. So this becomes 2 into 3 minus 1 into 1 plus 3 into 5, that is equal to 6 minus 1 plus 15, which is equal to 21 minus 1, that is equal to 20. So the scalar triple product of a vector, b vector, c vector, that is equal to 20. Okay, so this is the thing. So here is another question on scalar triple products. So here again we have three vectors: 2i cap plus j cap plus 3k cap, that is a vector. B vector is equal to minus I cap plus 2j cap plus k cap, and c vector is equal to 3i cap plus j cap plus 2k cap. So first we'll write it in proper order in determinant form. The x, y and z components be equal to 2, 1, 3, that is a vector, minus 1, 2, 1, and that is b vector, and then 3, 1, 2. So here you can either calculate the determinants directly, or you can use the manipulation of rows and columns to bring zeros, so that the calculation becomes easier. So we can do that also. So we'll write, this is row 1, this is row 2, this is row 3. So we can manipulate the rows as R1, we can write it as R1 plus 2R2, okay, and R3 as R3 plus 3R2. So why we have done it? See, So when we substitute R1 with R1 plus 2R2, that is 2 multiplied with rho 2 added with the elements of R1, this becomes, okay, R1 2 plus 2 into minus 1, this becomes 0. Then R1 1 plus 2 into 2, that is 1 plus 4, this becomes 5. Then R1 3 plus 2 into 1, that is 5, 0, 5, 5. R2, that is rho 2, remains as usual, minus 1, 2, 1. Then R3 is R3 plus 3R2, that is 3 plus 3R2, 3 plus 3 minus 3, 3 into minus 1, that is 3 minus 3, that is equal to 0. And then 1 plus 3 into 2, that is 1 plus 6, equal to 7. And 2 plus 3 into 1, that is 2 plus 3, 5, 0, 7, 5. So the reason why I did it, now we will pick this 0 minus 1, 0. So this becomes 0 into whatever we do it, it will be 0. When we take this way, first column, okay, 0 minus 1, 0. Then we'll have minus of minus 1, only this one is necessary, minus 1 into 5 into 5 minus 5 into 7, and then again plus 0 into whatever happens, whatever result it is, it will always be 0, so no need to calculate. So this becomes minus of minus 1 becomes 1 into 25 minus 5 into 7, 35. This becomes 1 into minus 10, that is equal to minus 10. The result is minus 10. So through simple manipulation of rows, any row, any way you can do it, so that it becomes 2 zeros and a single non-zero value. Okay, that is the best thing. The calculation becomes very short. So this is the thing. So the scalar triple product value is minus